Hello and welcome to this meeting of the Hertford Astronomy Group. I hope you've had a lovely day. I'm sure that you're going to find that this meeting is going to make it even better. So, my name's Alan and it's my privilege to welcome you to this meeting of the Hertford Astronomy Group. The format of the evening is that after a few opening announcements by myself, we'll hand over to Martin, who's going to give you a talk about things which you can see in the sky, and hopefully show us some pictures of things which are a bit harder to find in the sky with your naked eyes. Following Martin's talk, we'll hand over to Jerry, who will introduce this evening's speaker, Richard, who's going to talk to us about solar eclipses. And that's very interesting because later this month, on the 25th of October, there is a partial solar eclipse visible from the UK, but more about that later on. Following that, there will be a chance to ask questions through the chat facility, and then we'll pass back to me for a few closing remarks. Just a few housekeeping comments before we get underway. The first one is to those of you at the university, could you just please make sure your mobile phones are switched to silent or in the off position so that they don't disturb anybody? And to those of you in Zoom land, can I ask that you please keep your microphones muted and your hands away from the space bar, because that accidentally turns the microphones back on again. So without further ado from myself, I'll now pass you over to Martin. Over to you, Martin.
Here at the university and at Zoom, just going to do a short presentation before our main presentation. I'm going to do a little bit on stellarium first of all, which I've got behind us, just so that people can see roughly the things that will be visible by the eye or with binoculars, but also going to point out some of the places where some of the images that have been taken by our astrophotography section are in the sky relative, just to give you a rough idea where things are. So looking with stellarium at the moment, and we're looking due west. And if I just slightly bring this up, you can see here is what we call the summer triangle, which is star Deneb in Cygnus, Vega in Lyra, and Altair in Aquila. So these three stars normally are quite high up in the summer, but they're slowly moving westward now as the year goes on. But there's some interesting things that I'll point out that fall within the triangle, only because I've got some images that our astrophotography section have taken of some of these objects. So the first one I'm going to show you is here in Cygnus. And where the cross of the swan is here, there's the Crescent Nebula. We've got an image of that, and this whole area here taken by one of our members. I'll move out a little bit, and also I'll bring you over to this corner here. This is called the Cygnus Loop. You won't be able to see this with the naked eye. You'd need to do it with the camera because our eyes just aren't sensitive enough to pick up the image. But this is the remnants of a supernova. And you've got the east veil and the west veil, so I'll show you that later. And I've got one other. Oh yeah, we've got the up here. Can't quite see it at the moment. There's also there the Elephant Trunk Nebula. We've got an image of that as well. I'll show you that later. So cool because this section here looks like an elephant's trunk. But anyway, the images on stellarium of the nebulas aren't particularly good. But I want to really concentrate on the planets at the moment because they're quite prominent in the sky. So to begin with, I'm going to start southwest here at Saturn. It's much lower than Jupiter, but still it's slightly more yellowy color than Jupiter. Jupiter is very white in its look, but this, when you see it in the sky, appears slightly more yellow. I'm just zooming in here, so you can see Saturn there. You'll recognize it with the rings and a number of the moons there as well, Titan being the biggest one over here. So if you go out in the evening at the moment and look southeast, you will see that, southwest, sorry. So we move south and slightly up, and there's Jupiter. That's quite high up, very bright at the moment. If you look at it through binoculars, you'll be able to see at least 3 of the moons, I would suggest, and possibly 4. These 2 are quite close together, Ganymede and Europa at the moment, Io and Callisto. But you can definitely see the moons through a pair of binoculars. If your eyes are very good, you might be able to see them with the naked eye, but I can't. So we've got Jupiter, we've got Saturn, and the moon, of course, is very bright at the moment. It's just past full. So it's waxing now, waning, sorry. So we've got the moon. I've got some images of the moon I'll share with you in a minute as well. But not far from the moon, know that the autumn winter constellations are coming up. The Pleiades, you should be able to see these. These appear like quite small, bright stars in the sky, quite easy to spot. But if you look at them through telescope, you'll see they're very bright young stars. And with a camera, you can pick up this nebulosity around them. It's actually in front of them. So as we move past the moon, come down slightly, there's Mars. So that's almost northeast, in between north and northeast. And Mars this month and next month will be in opposition, be closest to us it's been for a long while, so it's a good time to have a look. So here we are, Mars. You can see the moons there, Phobos and Deimos. I've got some images of that to show you later as well. So why we're in this area, I was going to show you something else, which is another image I took. That's on my presentation. So if we come up from the moon and from Mars up at an angle, we've got the W in the sky here, Cassiope, which is almost overhead. And we've got this I can never pronounce this, Camelopardalis. And if you look with a pair of binoculars, this fantastic cascade of stars called Kemble's Cascade. I've got an image of that I can show you as well. And that's something you can look at with a pair of binoculars, and it's quite a fantastic thing to see. And you've got this Jolly Roger cluster at the bottom. So I'm going to switch now to my presentation. Okay, so the moon. This is an image taken by Steve Halitza, one of our astrophotographers. It's a fantastic image. You can see Velothus, Cyrillus, and Katrina craters of the moon, about 60 miles across. This, when the moon is slightly going into shadow, you can see a lot more definition, the craters. So that's a fantastic image, I think. So the moon, quite easy to find. Can't find the moon, you can't find anything. So Mars always appears slightly orangey coloured. It's not as bright as Saturn and Jupiter. But there's another image by Steve's taken. So Steve's been very busy taking pictures of the planets the last couple of weeks. So I'll just put a little bit of blurb there about Mars in Taurus at the moment. It's now only 2 months from opposition. So it's the best time to observe it, especially for imaging. There's a little bit of information about the magnitudes there, and about its movements. So when we tend to image these, we use fast frame video cameras, which capture lots of frames, and then they're all stacked together, and then to pick out the detail. The next image is Saturn, another one that Steve's taken. You can actually see one of the moons there. It's quite good. Is that a bit on my screen? No, that's a bit on my screen. No, there's the moon. Yeah, I see it's underneath. Yeah. So Saturn is visible in the evening sky, which I just pointed out to you. It just appears as a light, but with a telescope, you can see the rings. You can see that it's not completely round. So a good pair of binoculars will show you the rings as well. So definitely something to want if you want to observe. It's a good time to go and have a look. And Jupiter. That's a fantastic picture, Steve, of Jupiter. Well done. You can see the red spot there and the clouds forming. So I think Jupiter's got a rotation of about 10 hours, something like that, is it? So, you know, when you're imaging this, it can change very quickly. So you can actually do a video link to show the rotation. So this, I think, is fantastic, although it doesn't look very much. It's Uranus. Now, if you think about how far away it is, Steve captured this in his garden in North London. I think that's superb. And he says, my very first capture of the elusive, distinctive blue Uranus, taken small hours of the morning, 3 billion kilometers away. That's 3 light hours. That means light takes 3 hours to reach Uranus from the sun. Completely invisible, nearly impossible to find. And quite right, how the hell did William Herschel find it 250 years ago? But there you go. Well done. So this is a montage of the planets that Steve's have taken, and I think that's fantastic. So we've got the Moon, Mars, Jupiter, Saturn, and Uranus. Shame they're not all that close in real life. But yeah, that's a brilliant picture. Well done. So I talked earlier on about Kemble's Cascade. So this image here shows it in better, and this is the Jolly Roger Nebula at the bottom, cluster at the bottom. As you can see, appear almost in a straight line. 20 stars. This was taken by Bill McSorley in Leeds. When he took it, I don't know, but this was something I picked up off the internet. I just thought it was a brilliant picture and wanted to share with you, especially as it's something we can look at with binoculars or a small telescope and actually see it yourself. This is something also picked up off the internet, which I thought was quite interesting. We've been a lot of talk about black holes. I've spoken about them before. This one here is showing what they call spaghetti feast or spaghettifying, which is what happens with matter when it's drawn into a black hole. So this astronomers have witnessed 215 million light years away. And this was taken by the Southern Observatory in Chile. I thought this picture was fantastic. I found this on the internet as well. So I thought you can't actually see this in the Northern Hemisphere. It's the Southern Hemisphere nebula. But wow, look at the, this is all just star birth. This is all material, stellar material, creating new stars. It looks like a man almost standing there with a hat on, doesn't it? But that's Carnea Nebula. Say it's in the Carnea Sagittarius arm of our Milky Way. Approximately 8,500 light years from Earth, but as I say, it can only be seen in the Southern Hemisphere. So if you're going to Australia or something for your holidays, take a telescope with you, so you can see it. So I pointed out the Cygnus loop to you earlier on, which was a supernova remnant. I imaged this a couple of days ago. So it's a part of the Cygnus constellation. You've got 2 nebulas here. You've got, I think that's the Western Nebula, the Eastern Nebula, and this is Pickering's Triangle. The star that initially exploded, the supernova would have been around this point here and somewhere in the center of it. It's probably a neutron star now or a black hole or something like that, so not necessarily visible. So I've just put a little blurb there about it's the best observed old supernova remnant in the Cygnus loop. And you can see the filaments of the material that's been thrown off when the stars exploded. It's a little bit of information there about not being able to see all the material because some of the clouds are denser and can't see through them. So the Cygnus loop is supernova remnant from about 10,000 years ago, so that's quite a time. And the filaments are moving out about 100 kilometers per second, so it's moving quite fast. This is an image by Kevin Noble. I think I showed you the Crescent Nebula earlier on, but this is the full nebula going through here. So we've got the Crescent Nebula, the Tulip, and the Soap Bubble Nebula, all part in this part here. This is all part of Cygnus, but that is an incredible image. I forgot to show you where this was. This is the Bubble Nebula, also known as NGC 7635. It's an emission nebula in Cassiope. Well, Cassiope is the W that I showed you at the beginning, so it's in that area. The bubble is created by stellar winds from a massive hot 8.7 magnitude young central star. And I took that back in the summer, I think. Another one by Steve. This is always a popular. It took this when he was in Mallorca. It's our sister galaxy, spiral galaxy, M31 or Andromeda galaxy, sometimes known as. So I'll put a little bit of a blurb there. Although several dozen minor galaxies lie closer to our Milky Way, Andromeda galaxy is the closest large spiral galaxy. So it's 2.5 million light years away, and can be seen by the unaided eye. If you're in a dark sky, so it appears as a patch of misty light, really, I suppose the best way to describe it. And the interesting thing is that it's slowly, well, not slowly, it's quickly moving towards us. I think in about 4 billion years, our galaxy and the Andromeda galaxy won't collide because there's too much space between the stars, but they'll become one galaxy. They'll merge together. The last image, another one by Kevin. Thought it was fantastic. I did show you the Elephant Trunk Nebula there, but that image is spectacular. I'll just read a bit of the blurb. The Elephant Trunk Nebula is a dense region of dust and gas found within the considerably large star-forming area IC 1396 in the Cephus constellation. There's a bit of information about the designation and the visible wavelengths of light, but the distance from us is about 2,200 light years. And that brings me to the end of my presentation. So is there any questions? No? Okay, I'll pass over to Jerry then.
Thanks very much, Martin. As Alan said earlier, it is so nice to have you all online, but also back here at the Lindop Lecture Theatre following its refurbishment and this terrific huge screen here. It's really good. So tonight's main speaker, Richard Westwood, will be known by many of you as a member of the Southwest Hertford Astronomical Society. And in fact, the information that he sent me says that he was on their committee for 30 years. Those of us on the HAG committee must be thinking, I mean, no way. We're not that gluttons for punishment. He started his interest in astronomy from a pelican book, and he's now quite an interested observer. He has a 100mm refractor, which is a good size for a refracting telescope. That's quite something. And his subject this evening is, as you can see, eclipses. Can I ask how many people here have actually seen a total eclipse? And I really mean seen one, not did you go down to Cornwall and watch the clouds? So a few, okay, me too. After discovering eclipses when I was about 9 years old, because there was an eclipse which was visible when I was at primary school. Of course, back then there's no health and safety, and so fortunately there was an even layer of cloud which was able to partially block out the sun, so we could see the crescent sun through the cloud. And I was really impressed, not just by the fact of what I was seeing, but the fact that we could predict when these things were going to happen. And then when I got home that evening, I looked up eclipses in our copy of the Britannica, and discovered what a total eclipse was. And this really blew me away. And oh my God, there's going to be one in England. I'm going to have to wait 34 years for it, but I decided then nothing on earth would prevent me from being in Cornwall in August 1999. Until in about 1997, I started to make proper plans for that and decided that was the last place I wanted to be. According to some reports, there might be 1 million people down crowding this tiny, thin strip of land. Hotel prices could be 5 to 10 times what they would be normally. But the main thing was I just simply did not trust the English weather in the middle of August. And it turns out I was right. So I was in Vramnicu Vulture in Romania at the point of maximum eclipse and saw the whole thing start to finish. Well, as Alan has already said, there is a partial eclipse coming up, and I'll be saying something more about that afterwards, but I'm going to hand over to Richard to tell us all about this ultimate spectacle. Thank you.
Yeah, of course. Yeah, it's lying down. Okay. Thank you. Can you hear me? Okay, great. Well, thanks, Jerry, for that great start of presentations. Just finding thing to get the oh, it's on the screen. It's all right. Done it. You'd already done it for me. Thank you. Yes, I did the same thing. I learned about this great eclipse that was going to be in Cornwall, and I thought, all right, okay, go down to Cornwall. Goodness, I'll be old. And as it got closer, I began to think, not sure about this. And I asked several people, and people said to me things like, well, have you seen one? And I said, no. I said, don't go to Cornwall. Try something else, because you'll probably miss it. We're going because we want to see it from Cornwall. So I did. I went to Turkey, and it was great. It was a semi-desert, but it was good, and we saw everything very, very well indeed. It was really good. So, eclipses of the sun, as it shows there. What's the next slide? Oh, great. There we go. Well, one of the things about eclipses is that they can, am I blotting the image out too much for anyone? Not too much, I hope. Okay, they are, or were, to early man, very, very, very frightening. it's hard for us to appreciate now the separation in time, how frightening being in the dark is. We don't experience it. We just don't. We can't, because we are, there are electric lights everywhere. In fact, one of the biggest problems now is that there's too many. But in prehistoric, or the early man, the time of early man, when you have at night, if you blew your candle out or put a fire out, you were in total darkness. That was it. You could have developed a panchromatic film in it because it's totally dark. There's nothing you can see. So that would be really, really frightening. And then when something comes along and suddenly in the middle of the day starts blotting out the sun, you wonder what the hell's going on. Now, it's not really a surprise that most of the ancient cultures had a sun god and a moon god, because they were the only two sources of illumination. Fortunately, when you had the moon, you could do things around. That's why, to some extent, the moon was so important. It was fickle, so that's why it got them. Often they were goddesses, because women are fickle. The old sort of thinking that they bestow their favors and they disappear. So you can understand that this apparent blotting out of the sun during the day is a bit of a pain, and actually very, very frightening. So what did it do? Well, the first obvious thing to do is that you bang a few drums, you've shouted it, and you try and make it go away. And of course, it does go away. So you've got rid of it. Well, that's good. We'll do that again. But of course, there are some rather specific things that happen. For instance, in India, pregnant ladies, they were banned and they had to stay indoors. Now, it seems to me that there's a lot of things in the sky or in general that ladies get pushed inside, or there's something they have to do. And but that seems a particularly strange phenomenon. Men, on the other hand, could watch it safest if they were in the Ganges, because you didn't quite know what eclipses were going to do. German tribes thought the eclipse was a kind of rainstorm that spread epidemics and bad vapors, etc., on the earth. Although, really, what evidence do they have? But of course, eclipses don't last very long, so they quickly get forgotten, and we go on to the next thing. Tahiti, they had a really complicated system. I was quite really astonished to read this. The sun and moon are lovers. Their union creates the eclipse. But in that darkness, they get lost and they create the stars so they can see their way again. Now, I'm not sure quite how they fit that together, but it's quite typical of a lot of the myths surrounding the eclipses, the way nature shuts down. Because the thing is, it's not just a matter of losing light. It's actually a matter of nature appearing to shut down. I mean, bearing in mind that by the time you come from a hunter-gatherer to somebody that's doing agriculture, you're very dependent on things like that. You're much more dependent than the guy that can give a few grunts to his mates and they go off and kill a deer or something and come back with it. You're actually trying to grow something. So anything that interrupts that flow is a worry. So you can understand that that's why you've had these various superstitions, etc. Now, of course, occasionally, in the case of later in the ancient history, you've got things like the Lydians and Medes stopped fighting on the May of 28th, 585 BCE. They did that because there was an eclipse. They declared a truce. That's really astonishing. I mean, it impelled them to do something about it. Later on, the great person that lived in ancient Athens, Pericles, in the middle of a war with the Persians, some of his people saw the sun becoming blocked by an eclipse. So he looked at it and he said, well, look, I'll put my cloak up. It's eclipsed, isn't it? Carry on. So obviously that kind of thing has worn off. Now, the illustration that I've got from here, this illustration, is there for a reason. Because in actual fact, That is from a book that I've had since I was 10. And hence the date of this thing. The book was published in 1956. I got it in 1958. And the reason I put it there is because David Levy gave a talk. Made an article in the Sky and Telescope quite a few years ago now, and he used that very illustration. So we were fortunate enough, Jan and I, we went to Arizona in 2003, and we actually met him. And I said to him about this illustration. I said, I know where you got that from. And he said, yes, the Golden Book of Astronomy. And I said, I know, I've got one. I had it for my 10th birthday. And he said, so did I. And the funny thing is, he is exactly 11 days ahead of mine. My birthday is the 11th of May. His is the 22nd. So it was one of these odd things that's bound to happen sooner or later. So we think we're so smart. We think we're much more sophisticated now. We don't do things like that. Okay, well, there's an illustration down here of the Arabs in Libya, and they're actually looking away from the sun because Muslims mustn't look at the sun. And they're looking away and they're praying. And there's one in Egypt. This is Egypt, the guy on his own. And he is actually looking at it because different parts of Islam react in different ways. When we went to Turkey, oh, great, pass the sunglasses round so we can see the sun in its eclipse, you know, no problem. But in Indonesia, when a group went in the 1980s, they found everybody disappeared inside. Now, then we come to the Babylonians. Now, the Babylonians were an amazing group of people. They actually did a huge amount of work in astronomy. They were perplexed by all these things that happened, and they decided in the end the only way to sort this out was to record everything. And I mean everything they did. And this is not just for sort of 50 years. This is for a couple of thousand years. They were recording everything that happened in the sky. That included eclipses, the motions of the planets, all sorts of things. And they recorded them on these cuneiform tablets, which are clay tablets, which are engraved with a little stylus. And over here, you have the place they did it from, which is the ziggurat, which is basically a tall building. It was actually a temple, but they observed from the roof. So these cuneiform tablets, they carried so much information that over a period of thousands of years, they discovered patterns, repeating. And they eventually found out something that we now call the Saros. So that to them was a word meaning universe, but we call it the Saros period. And that is that eclipses tend to go in patterns of 18 years, 11 and a third days between eclipses of the sun. They repeat. And so with all these other things that were done, they can actually predict eclipses to some extent, very limited. But really that came later. And this device here next to it, this machine, the Antikythera device. Now, this is I have to sort of blink twice when I say this, because that was actually a calculator. That was a Greek calculating machine that could calculate positions of the planets and also eclipses. It seems incredible they could do that. So 2,000 years ago, they had a machine that would do that. Now, we're very fortunate with the Southwest Astronomical Society because we have Aris Denarkos, I can't pronounce his Greek name. He is the one of the research people working on the Antikythera machine, as well as being head of science. So he's given us two very, very good talks on this subject, and it is amazing how accurate it is. In fact, he said, I shouldn't be saying this, I'm Greek, but it was the Babylonians that provided the figures, because that's where it all comes from. Now, the moon's orbit. Now, the moon, all right, the moon goes around the Earth. The Earth goes around the sun. Sounds simple, doesn't it? Devil's in the detail here. The fact is that the moon does go around the Earth, although it's a little bit more complicated because the center of gravity of the system is actually below the Earth's surface. So it's not exactly goes, you know, they kind of revolve around themselves in a way. However, you have the ecliptic. Now, all the planets and the sun go around on the ecliptic, more or less. Moon doesn't. The moon is 5 degrees inclined to the ecliptic. You have 2 points at which it crosses the ecliptic, that there and there. And that is, if you can imagine 2 hula hoops put within each other, and then one slightly up and one slightly down, you've got the general idea. So it's 5 degrees difference. So that means that we cannot have an eclipse when the moon's orbit is higher or lower than the sun, than the ecliptic. We can't do that. So what actually happens is these 2 positions where they cross, which are called nodes. There's just a crossing point. There's obviously two crossing points. So they can only happen when the moon is in the same place as the sun on the node of the orbit. Now it makes sense, you can understand that, but what happens isn't quite that simple, because this node has a thing, it regresses, it actually travels around. So this traveling around gives you the time interval. So you've got the node actually moving in the orbit. So you've got to actually have 3 things aligned. You've got to have the moon on node, and the node being precisely between us and the sun, so that it creates an eclipse. Now, one of the things that astronomers always talk about is in astronomy, we use the Copernican principle. The Copernican principle states that nothing on the Earth is special. We are not special. Our orbit isn't special. Our place in the galaxy isn't special. So we're not. But when you look at something like this, you've got to think this is a lot of coincidences. The reason it's a lot of coincidences is because you've got to get that node in the right place. The sun and the moon have to be exactly the same size in the sky. And that's the amazing thing. The moon and the sun are actually half a degree in diameter on the sky. That's in angular measure. More or less. The moon actually is not in a circular orbit. So occasionally it's a little bit closer to us and sometimes a bit further away. So that's the reason you get different kinds of eclipses. Annular eclipses occur when the moon is at aphelion. In other words, it's further away. Sorry. I can't think of it's not perigee, it's apogee. That's the right one. That's the one I should have used. It's at apogee. So, and if you get one when it's at perihelion, then it's actually covers the sun very well, and you get a longer eclipse for other reasons. But it's a hell of a convenient thing. And if you look at, for instance, I looked this up. Jerry was saying to me about Jupiter and can that have eclipses? Well, it can, but it doesn't, because the sun is such a small angular size from the distance of Jupiter. We don't get the same effect, although you can actually see the spots moving across. And in fact, I've got a little plan here showing the path of a typical eclipse, and the path is never the path of the actual total area. That area of totality can never be more than 150 miles. That's it. So you're looking at a tiny scratch across the surface of the Earth where you actually see what people would say the full Monty. If you want to see an eclipse with the corona and things like that, you really do need to be in that 150 mile zone, preferably in the middle. So it really is a very delicate balance, and you've got to say that well, that really does push the bounds of chance quite a lot. I mean, as far as we know, it doesn't happen anywhere else. There might be another exoplanet in sort of Cygnus X or somewhere that's got some that we don't know of it yet. So, eclipse tracks, which I've got here. Now, this one is taken from the book that I showed a picture from earlier. And here you can see typical eclipse strip. Now, these were taken in 1956. So it doesn't actually show the one from Cornwall because that was too far into the future, believe it or not. So It does have some interesting ones, though. It has the one that went across Africa in 1973, this one here. Now, that was the one that the BAA and the Croydon Astronomical Society and a lot of people went on a boat, Monte Umby, I think it was called, where they had a marvelous time. Everybody was on it. Everybody was known at that time. Norman Fisher, Patrick Moore, Commander Henry Hatfield, all the Horace Dall, they're all there. They had a marvelous time. They didn't like what country, can't think of the name of the country they went to. But anyway, it wasn't a very nice place. It wasn't Mauritius, it was something like that. But they went there and they spent a day there and they came back very, very quickly. Mauritania, sorry, that's the one. We actually went on a trip by boat and we actually stopped there. And even on the boat, it smelt pretty much of fertilizer. And we didn't have the privilege of having because we couldn't get our passport stamped to go abroad, to go onto the land. We sat and watched it and it wasn't very interesting. And people that came back said, well, it was good. Well, sort of. So anyway, but yeah, so that was one. The other one that's important is this one here that goes across, like this, the 1961 one, the 2nd of, I think this is the 15th of February. Now that was 1961. Now there's several things about that eclipse. It was the first one shown on television because that was the one that Patrick Moore filmed from Yugoslavia. Another couple of things about it, it was the one that I saw from school in our science lab when I was in the 2nd year. And I remember seeing it, as Jerry probably did the same, with a piece of smoked glass, which is not really the right way to do it, but there we are. It also has a rather strange claim to fame. There was a film released in 1962 called Barabbas, which featured it's the crucifixion, and you've got Barabbas, who was the thief that was let off, and you've got Jesus, and it's actually shot at the time of the eclipse. The director, Richard Fleischman, I think his name was, I think it was Fleischman, he wanted to do this. I've not seen the film, I couldn't tell you what it's like, but that was what he did, because he thought, well, in the Bible it describes it as a darkness at noon, and that must be quite important. And so, you know, maybe it was a total eclipse. There wasn't one, and although strangely enough at that period, other places did say that it was a darkness at noon. It's written in other reports, but it was not eclipse. This one here, this is a modern one, of course. This is the track of the eclipse that Jan and I went to in Idaho, and you can see the USA, as usual, gets a really good view of it, and it shows that the total zone and also the parts where you get a partial phase. It also, there's another one going through this same area in I think it's a couple of years' time. They seem to have a great, I don't know why it is, what it is about the States. Europe is very, very unlucky. Another character you might not think of in connected with eclipses is Edmund Halley. Now, Edmund Halley was a great astronomy popularizer. He was very much an international man. He'd been to quite a few countries. And one of the things he did, he produced an eclipse map. Now, one of the things, first of all, that Halley did that's really important, he got people interested in comets by proving that the superstitious stuff of them being harbingers of doom was just not true. You could predict them. And below his prediction, the one about Halley, he actually died some years beforehand. But funnily enough, in France, he was hailed as a great man. And England said, yes, he'd got it right. So maybe he wasn't very much in favour at the time in England. But using Newton's calculus, they managed to work out that the comets return. In 1715, he published an eclipse tracts for 2 events. An eclipse in England on May the 22nd, 1715, and the 11th of May in 1724. The third map was an extended map of Western Europe for the May eclipse. He actually adds a little thing in it to say that he's doing this so that people will know that if it gets dark, that there's nothing, it's just something that's predictable. But I've got to say that he must have been the first person to invent the eclipse track, because what does that look like? It's an eclipse track, isn't it? Yep, there's an eclipse track. You can see it. There's quite a lot of there's written material down here, which is where he explains why he's done it. Also, there's another added thing here, because his job after, or the thing he was when he became Astronomer Royal, Flamsteed had done the Star Atlas part of the job they were working on, which was finding longitude at sea. He'd made the star chart, and now it was up to Halley to improve their knowledge of the movement of the moon. Believe it or not, the moon's motion is quite difficult to get right. In fact, to be honest, the motion of planets has the same problem, because when I've spoken about the Babylonians making patterns, the Greeks and their Antikythera machine actually just used the patterns. They didn't work, it wasn't the real sky. And even when Copernicus came along and actually produced the figures that you could work out using the real sky, the real planets, they were seldom better than the ones that predicted otherwise, because it took Kepler to work out the business of the elliptical orbits, and it took Galileo working out the dynamics of moving bodies, and Newton to put it all together before we had a reliable way of working that out anyway. So it was a much more of a colluminative effort. A lot of people were involved. Actually, that wouldn't have happened when things began to improve. People had stopped, fearing eclipses, not looking at them, and they began to look, and people began to draw their impressions. And here you've got a picture that was painted, or actually it's a pastel. Etienne Trouvelot. He's a Frenchman. He was entomologist and astronomer and an artist and several other things. And he was actually invited to work with Harvard College Observatory to produce images of celestial phenomena. In fact, they let him loose on a large refracting telescope to do some planetary work as well. But to be honest, they do look a bit somewhat, they don't look how we would see the planets. But this is a really good, very good drawing. And it's actually it's more accurate than you'd think. He's drawn it much larger than you would think, than you'd see it, which is probably the way artists work. But the funny thing is that I'd seen this drawing before, but when we went to the eclipse in Idaho, I was watching it with a pair of image stabilized, good quality Canon binoculars, very small, just a 30 by 12, I think they are. But the streamers that come out were remarkably like this picture. They had an Art Deco look about them, which is what this picture really gives. Also, he was the first person to draw prominences, which you can see here. Very good artist. He was, of course, the thing about Trouvelot, unfortunately, was a big entomologist. He'd taken some of his moth samples to America, and there was a particular moth called the white sugar moth, which liked America rather more than it liked France. And when he came back in the wake of dying trees. Everywhere he went, that sort of had got trees that were dying, and he's responsible for killing quite a lot of the native species in America, which is not maybe the best thing to come back after doing. Now, Leslie Ball, I couldn't find anything else about him for a long time until I read a book that talks a lot about Patrick Moore and his associates. 2 books. It Came from Space Wearing a Blue Blazer, and the Dark Side of Planet Moore, I think it's called. And he talked, the guy that's writing it, Martin, I can't think of his name offhand, but he actually talks about Leslie Ball, because otherwise he'd disappear a character. He was a BAA member, and he did a lot of artwork for Patrick Moore, particularly the Observer's Book of Astronomy. Did anyone have an Observer's Book of Astronomy? Yeah, I think it was a kind of staple. In fact, I lost mine, and I went to the I belong to the Society for the History of Astronomy, and I went along to one of their meetings and found one, and I picked it up, and it was originally owned. It had the signature of Gilbert Scatterthwaite, who was quite a big wig in the BAA and the RAS. So even he had a copy, 1964, and it's got all these marvelous pictures of the planets, etc., that we all wanted to see. So that was that at least was getting kind of visual things and people putting things down. You're getting sort of reasonable descriptions of what things look like. But of course, photography is we say it's the ultimate. It isn't the ultimate in some ways, but it's a much better, much more accurate way of recording, even to scale, etc. Now, this image here is the first daguerreotype, which the early daguerreotype was the very early form of photography. It really was very difficult to do. I'm not even sure I know how to do it myself, but it involves lots of chemical things that are noxious, like mercury. It's not an easy way to make photography. Then, of course, came the wet plate process, and eventually the dry plate, which is what you've got here, which is, I don't know where this particular picture, who took it, but it's May the 28th, 1900 was when it was done. You can see that it's much more subtle. You've got much more better tonal rendition and there's a lot of better things about it because it's got detail, and the detail is much more extended into the lighter tones and the darker tones. In fact, as a ex-camera operator, the mid-tones are much better represented. And you come right up to the end of film, film photography, and this is a triple exposure or triple plate made up using Kodak Royal Gold. And this is the wife of Mr. Espenek, who's Mr. Eclipse, that does all these eclipse predictions, etc. The one over here is, I'm not sure about this. It says it's a photograph, but I suspect that it's been artistically wiped. I think it's a kind of amalgam of techniques. It's published by Cassell and Company, and the previous drawing of the prominences are in a very old book of mine by Robert Ball, The Story of Astronomy, which is got brilliant pictures in it. It really does go back to in fact, he talks about the very last transit of Venus, the one before we saw, the one in 2004, and he makes the comment in it that he hopes people from 2004 will have as much enjoyment. But it's a brilliant book, but it's got these fantastic illustrations as well. So then we get on to more science subjects. Now, one of the problems that came up in 1915, Einstein actually published the second part of his theory of relativity, the second part, the special part. And in this is a part that deals with the light being refracted or moved or warped by passing a massive body, such as a star. Now, everyone was very skeptical, but Sir Arthur Eddington, who was actually a very popular man, he was the first guy to do radio broadcasts, scientist to do radio broadcasts. But he was very much in favour of Einstein. He thought, the guy's right. And he was actually a very, he had two notable successes. He worked with Chandrasekhar and for a limited time, and actually disagreed with him about his ideas to do with stars that are very, very massive and what happens to them at the end. He couldn't agree with him about that, and they split up. They had a very amicable, bearing in mind it was a technical argument, they had a very good experience. Other than that, they remained friends. His protege was Cecilia Payne, who in the end was so good that she left England and went to America, where she became Cecilia Payne Koposhkin, who was, apart from writing a very good book called Stars in the Making, which I've read several times, written in the 40s, she was the person that discovered that stars consist mainly of hydrogen, very important that, and that hydrogen is the principal component of all stars. Anyway, this debate, the only way it could be sorted out was by doing a photograph of the sun at an eclipse and having noting where the stars were in relation to the sun and comparing it to another picture, another plate taken in the winter time, in this case, to show the sun, to show the area without the sun there. It did work. It poured with rain up until the eclipse, and they managed to get their photographs from Principe where they were working, and they managed to find that the deflection was exactly as Einstein had predicted it. Although, to be fair, several other observatories that did a similar test weren't quite so sure. But the story is that he was accompanied by a guy called Coddington, and Einstein knew, Eddington knew that Coddington would have been said, "I don't know if you'll end up coming home alone from this eclipse trip." And so Eddington turned to him and said, "Coddington, you will not have to return home alone," because his results confirmed Einstein, and therefore we're all. It is.
This was more of a publicity.
Yeah, it really wasn't. They even tested it again in the 1973 eclipse. That was they did it several times actually, but the last time they did it was in 1973. So there still was, yeah, it was arguable. It really, it was.
I mean, obviously there's lots of other techniques that much more accurately, than this.
Yeah, but in 1919, it wasn't quite. They didn't have the modern. I mean, yeah. I mean, now we know because you get distant galaxies warped by things and stuff like that. But of course, yeah, there was no way of doing that. And to be fair, using the seeing conditions could alter things that much. It really is marginal, but it sufficed. And but say particularly Lick Observatory weren't that happy with it. One or two, yeah, they did really think it was a bit odd, a bit spurious. Now, the trouble is with studying the sun is if you want to see the corona, you really have to look at it the eclipse time of eclipse. So Bernard Lyell, I imagine that's how you pronounce his name, developed a thing called a coronagraph in 1930. It's a device that has lenses and an obstruction placed in the center to block out the sun, but you have to use it for very high altitudes. In fact, they still use them. They're still using them, I think, for studying exoplanets. But the original reason was to study the behavior of the corona. And here you have, obviously, Bernard Lyell working on one of these devices here. There's an optical train here showing where the obstruction is placed, and but the trouble is it blots out the inner corona anyway, so you don't get the full thing. But it did work, and it enabled them to study the fact that the corona changes with time, and also it began to show that something affects the corona. Because then we come on to spectroscopy, and that is to some extent the magic key. It's the magic key to astronomy, really. I mean, if not spectroscopy hadn't been devised, then there would have been a real problem, because you couldn't determine what substances were present in anything. This gave an absolutely brilliant answer. Not only could you see what elements were present, you could also see if they were receding or if they were approaching. You could see if they were spinning rapidly. You could even tell if it was a magnetic source, because you'd get twinning, the Zeeman twinning effect. And in fact, they found that on sunspots. Now, sunspots, the sun has a variability period with the development of sunspots and thus activity. This was discovered by a guy called Henry Swabe, who was a German. In 1826, he realized there was a problem here, and he set about to solve it. And it took him 30 years before he finally announced to the public that there is a curve of roughly 11 years in one direction, 11 years in another in sunspot activity. And that affects the corona by making it different shapes at time of sunspot maximum and sunspot minimum. So that immediately gave another clue to the the corona and its way it moved. And also it gave an idea about the prominences. And the guy who sorted that out was Jules Janssen, who was French. He discovered using a spectroscope that it was hydrogen emission that was causing this brilliant red flares, etc. And he was the person that that realized that you could actually see these things without necessarily going to an eclipse. He did go to the first eclipse he went to in 1868. The second one he went to, he had to escape Paris because Paris was under siege. He escaped by using a hot air balloon to get to the location where he got to go. He was an enterprising character, very clever guy. Later on, in the 30s, using spectroscopy, Edlin and Grodin showed that the corona was composed of very tenuous hydrogen. In fact, there is some helium in it, but they suspect that's coming from other sources. And it was a plasma. It was extremely hot. It was 2 million degrees K. When you bear in mind that the surface of the sun is at 6,500 degrees K, that's a huge jump. And in fact, the chromosphere, the red glow, where the prominences are, that's at even lower temperature. So how does the energy from the sun get through that? And that was a problem that baffled scientists for an awfully long time. It was only solved quite recently with above the atmosphere spacecraft. Now, a lot of research was done by people on the Earth as well using equipment, but when you're in space, the whole wavelength of astronomy of the electromagnetic spectrum is available to you, from radio right up to X-rays, gamma rays, etc. And it was later shown that the suggestion by Hennes Alphen, the 1940s suggestion that the magnetized clouds of plasma could carry huge amounts of energy along the sun's field from the core to the corona. In other words, there are channels. And that apparently is right. Now, the strange thing is we've had several speakers at the Southwest Hearts on this subject, because it's been going for an awfully long time. We've had everything from solar seismology, because the sun actually is vibrating. It's vibrating in patterns. It really is a very vibrant body, believe me. And that was thought to generate heat, but it isn't that. It is this business with the magnetic flux, and that is what shapes the corona. But it is, I mean, it's intensely thin, but it's also very, very hot, which is a strange combination that we don't come up with in modern thinking. Then the amateur strikes back. Good to strike back, isn't it? We began to be able to, up until then, all we've been able to do was sunspot drawings and photographs. All of a sudden, last 20 years, we've had access to these hydrogen alpha filters, and you can do all sorts of marvelous things with them. And maybe the age of going to eclipses is maybe coming to an end. I don't know. Hope not. We'll come on to that in a second. So go on to the second to last slide, and that is the eclipse experience. Now, I've been on 4 different eclipse trips. I've had success on 3 of them, and a bit of a failure on the third one, the fourth one rather. So I've seen 4, been to 5. That's it. Got it right. First one in Turkey, brilliant, absolutely fantastic. Second one in Zimbabwe, that was really good as well. The one in Turkey in 2006 was rather strange because it was Turkey again. That's why I went. That one, we've just come out to totality, and we'd all ordered pizzas from a van. The pizza van turned up. It's just 99% of the sun's gone. What do you want for your pizzas are ready? So there are people saying, did I order cheese or did I order meat? You know, thinking, what? Anyway, so the fourth one that we did together, this is the thing, we had some really strange experiences with horses that came up to see us and other things. This is the nice effects we got in the eclipse. The third one, the one in 2013, we went on a boat. It was a very special boat. It was the Sea Dream, and they had 150 people on it, and it's very exclusive, very luxurious thing. They were using it as a shakedown because it was going for repairs and whatever, and they wanted to sort of use it up for a trip that didn't worry about whether the bed linen was exactly square and everything else. The guy that had the least amount of work to do was the hairdresser on the ship. He really enjoyed it, so it's really good. Nobody worries about whether their evening, their hair is okay for this evening or things like that. Nobody worried. But unfortunately, we lucked out, as you can see here. We're wearing eclipse glasses. We've got all the things, but there's the sun, and it really didn't work. So it was sad. It was a success in some other ways. We got to see some things in Barbados we wouldn't have seen. Jan had a swim with some turtles, and I fell in the water afterwards and got wet. Yeah, one or two interesting things, but it wasn't quite how we expected it to be. We would have liked to have seen the eclipse, and to be honest, we didn't get many clear nights in Barbados either. So we weren't there a terrific length of time. We had some really terrific food. Honestly, fish out there is really good. Okay, so that's one of the pictures that I took from this. Now I'm going to go to the last slide, which is actually my conclusion. And I'm thinking this while I was writing this talk. The most remarkable fact, I feel, is that thanks to our ancestors putting aside ignorance and fear, which are very strong, we are able to understand and enjoy one of the most amazing and awe-inspiring sights in nature. Now, before I just finish, I was just going to say, anyone, I'm wondering about what do people feel? Some people have been on eclipse trips, some people haven't. But do you think it's better to now take your HA pictures and you can go to YouTube and see the eclipse? Anybody in favour of that idea, or do you want to still go and see the eclipse? Anybody, any ideas? Go and see it. Yeah. Oh, good. That's one thing. It came to me a few years ago that children were getting too used to seeing screens. We went to Whipsnade one day, and we noticed that one couple was showing, it was a zebra or something over there. So they get the tablet up and, oh, there's a zebra. And the kids are actually looking at the screen. I thought, just show them the real thing, for goodness sake. Nothing can beat the real thing. So with that, I'll leave you. Thank you very much for listening. That's really nice of you. Thank you. Okay. No, just extract that.
Thank you very, very much indeed for that. Just hang on there. So over to the audience, in person and online, for any questions. Do we have any firstly? Okay, anyone here? Yes.
Have to wait till next full eclipse that would be viewable from this country.
Don't hold your breath.
It'll be academic.
Yeah, yes,
Yes.
yeah. No, we the last one was in 1927, and that was only visible from Eclipses, which is up in the Derbyshire area. We had to wait a long time for that one, and we had to wait until 1999 for the next one.
Yeah.
So I think they come up, so every lifespan gets one, but you don't get another in the same place. I mean, it's a contrast to Turkey, where the eclipse I went to see in 1999 was almost the same place they went for 2006. They crossed, but it's quite rare. The only place that gets them regularly, of course, is the USA.
Yeah.
They seem to worry about traveling. Maybe God sends more of these eclipses to them because they don't know how to travel everywhere. They don't know how to do it. I don't know, but it just seems that they've had eclipses every decade is always
Richard, you go with your 2006 trip. Where were you in Turkey?
Where was I?
Richard, sorry, could you share the microphone, please?
Yes, we did.
Yeah.
When was it?
because I actually organised a trip
Right,
for 10 of us from Letchworth,
right.
and I think there were some people from Southwest Herts
That,
who went on that. And we were not at Sea Day, which is where a lot of people were, but a hotel just a little further up the coast, which was precisely on the centre line.
right. It wasn't near Antalya, was it?
It was south of that.
Yeah, because a lot of Southwest Hearts went there.
Yeah.
No, I picked up because Jan was originally going with me. I thought we won't do an eclipse trip. We do it with some other way. I went with a group that were outward bound people. I didn't know this, so we actually saw it from the not far from the Garima Valley. So that's more
Okay.
further up. But so it wasn't in Talia, no. Although a lot of
Right.
people did see it from there.
Yeah.
Americans went there as well.
Okay.
Okay.
Any other questions from in the room?
You said the Babylonians said the eclipses happened every 18 years, 11.3
Yeah.
days, something like that.
Yeah.
Which is a number I've never heard before, but they'd only have seen eclipses that went over their territory. I mean, is that like anywhere there, and how big was their territory? Because
Right.
Britain sure as hell was.
So for people online, the question is that Richard mentioned how the Babylonians recorded that eclipses paths were being repeated roughly about every 18 years. And obviously that would have only been for those that passed over their territory. And as we just heard, we don't get eclipses in England every 18 years,
No.
unfortunately. So
Yeah, the thing was what they did, they actually declared a space for an eclipse. If it didn't occur, that was all right. They did this a lot. For instance, there were in Assyria, if there was a total eclipse of the moon and Jupiter was nearby, the king was in danger. Now they didn't, if they went by the predictions, they were sometimes wrong. So what they did, they declared a period where he could be in danger because it might not happen. So that's how they worked it out. And what they did in their case, they cheated. They told the king he wasn't king anymore. They got a prisoner and treated him very, very well for about a month. And then they killed him and brought the king back. So the king was working in the background. So it was kind of, yeah, they did things like that. Oh, they cheated. But if you examine records going back over a very long period, you can see there's a sort of periodicity of them. So yeah, that's quite true, because the 2/3 days movement, the third day's movement would actually turn it through a significant amount of the Earth's rotation. Yeah, you're quite right. But it's just that, and also there are several series going on at the same time. So I don't know how they worked it out, but they really did. But then they were very, very good at mathematics, and they were very, very good at statistics, which probably would make them very good in the modern world. Actually, they're good at statistics. Okay, thanks very much.
Right.
Thank you.
any others? Yes, at the front.
Why did you chose Idaho? Because, for instance, I was in Idaho for the
The question is, why did Richard go to Idaho for the American eclipse?
Because it was the only place that the eclipse people that we had were going to. That's why. I don't think I would have necessarily gone to Idaho. Some people went to Jackson's Hole, which is a bit further down, bit further over near Yellowstone. But we went there because there was a company in Manchester that were doing it. We found that we were because we'd booked fairly late. Everything that we did was not up to what we thought it was going to be, and it was quite a shambles. It really was. We nearly didn't see Yellowstone National Park. It was that bad. And the eclipse trip, we had an astronomer with us. I won't say his name. He was a journalist actually, and he decided he wanted to go right up to the top from Ben and Boot, which was where we were. And there's a big cinder path going up, shot up there. We had to wait for him to finish all his observations, etc., come back down before we could leave. We were the last coach out of the car park. We were caught up in the most enormous traffic jam. We ended up having a hamburger, which Jan fortunately got from McDonald's on the way, back to the hotel, because when we got to the hotel, it was 11:30. So yeah, he was not really much of a help, to be perfectly honest. We'd never seen any of his pictures. It was wanted to go up to the top, and so no, not very much. Thank you very much. There we go.
Okay. Any last questions? Anything online? No, okay. In that case, it only remains for me to ask you to give Richard a terrific round of applause to thank him for his presentation.
Thank you. Thank you very much.
Well, I'm going to talk about our event. Okay, so as I mentioned earlier, we have a partial eclipse coming up on the morning of October the 25th, which is a Tuesday morning, and it runs pretty much from 10 a.m. until just before 12 noon. So we're planning to hold a public eclipse watch in the center of Welwyn Garden City. Now, those of you who know the area will know that the area of Stone Hills has been completely refurbished and repaved and everything. And there's a big paved area next to what they now call the Anniversary Gardens, which is just close to the archway where we held an eclipse watch in 2015. Right, okay. That was incredibly cloudy, and the clouds cleared to an extent just at the point of maximum eclipse, and we saw this lovely thin crescent sun. Well, this time only 15% of the sun is going to be covered, and if you didn't know it was happening, you wouldn't realize anything was going on. But we hope to have a solar projector, telescopes with solar films, solar telescopes, hydrogen alpha, and possibly to fit a webcam on a telescope and use a digital projector to show a large image so that lots of people can see that all at once. So you don't need to book places for that. It'll all be completely free. You just come along between any time between 10 and midday, and we hope to be able to show you this terrific site. I might as well say at the moment, any members of the society who can help out on the day, if you can just give me your names after the meeting, that would be good. And then following that, we have another public event on the following Saturday, the 29th, another in our series of where we help people with their equipment, either that they have or that they're thinking of getting, called My Telescope Doesn't Work. Always blame the equipment. And anyone interested in that, watch out for an announcement giving the location, hopefully in the next few days. I think that's about all I have to say, and I'm happy to pass back to Alan.
Okay, well, thank you very much indeed, particularly Richard, for such a fascinating talk about eclipses. Thank you for all the work you put into that presentation, which was very, very enjoyable, and by goodness, certainly learned a lot from it. So thank you very much indeed for that. Would particularly also like to thank the tech team, Steve and Dan, because those of us watching on Zoom would have noticed a fantastic increase in quality of image and sound. So a very special thank you to you too. Now, I said we'd got some other special announcements to make, which are very important, particularly the next one for our meeting on November the 9th. That's the date of our next meeting here at the university and live on Zoom. At that meeting, we've got Peter Goodhue coming along to talk about discovering and imaging planetary nebula. Now that's going to be fascinating in itself, but I want to draw attention to that's the same date as the next Institute of Physics lecture in the Lindop building. Now, I know some of our members, quite a few of our members, like to go to the IOP talks as well as come to ours. So on that particular day, we're going to start our meeting half an hour later. And instead of the room where you are now, it's going to be in the room A161, which is actually just next door to the one you're in. So when you come through the two sets of double doors, where you've gone to the left to get into the room you're in, instead of going to the left, go to the right and to the far end, and that will take you into room A161. So remember that. We will put all this on newsletters, but do remember that one is starting at 20:30. That will give you time to go to both. Also, another date for your diary is November the 4th. That's the first of the Bayfordbury Open Evenings. Now, those open evenings do charge the public to come along. However, if you want to come along and help the Hertford Astronomy Group, we have a stand there where we promote the club and talk to people about astronomical things, anything they want to talk about, but obviously promoting that we've got a club in Hertfordshire that they can come along to. Also, of course, if you've got a telescope and would like to bring it along, if the night is clear, take it down to the same area as the university have their telescopes set up down by the domes. You can set yours up there and you can let members of the public see what can be observed from your back garden type telescope. When we've done this in the past, I think the overwhelming comment we get is that the back garden telescopes seem as good as the ones in the domes. So you're showing people that you don't necessarily need to spend thousands and thousands on a telescope. You can go and get really good results from almost any telescope. So there's an opportunity. And of course, if you come along to help Hertford Astronomy Group, then the entrance fee is $0. Okay, so all these, as I say, will be put on newsletters for you to observe, and you can make a note of the dates in your diary there. Just one last final thing to say, that those of you who were around in 1999 and had that rather unsuccessful journey down to Cornwall, what a shame. You should have gone to Devon, because at Torquay, sitting on the pier, just at the right time, the clouds parted. And those of us who just saw the last part of the eclipse in the United Kingdom before it went across to the French side of the channel, we actually had a terrific view of the total eclipse. I just say that to rub it in at the end. So thank you to everybody who came along, both at the university and on Zoom. Do have a safe journey home, and we look forward to seeing you either at our next meeting or at one of the other meetings that we're having en route. For those of you at the university, the meeting ends here. For those of you who are on Zoom, we can just carry on and have a little chat if you want to for a little bit longer. So thank you everyone for coming along and making this evening really good. Thank you and goodbye. Bye-bye.